Hello everyone, welcome to your topic 5 ticket to retake video. Um, Use this video however it may help you. I'm just going to go through and reteach the problems in this review, and if you just need to jump to specific ones, feel free. This is your retake, so just whatever will help you out. But definitely use it as a way to check your answers, but you can listen into the problems you need more help with. All right, so numbers 1, 2, and 3, we have to rewrite using a fractional exponent. So let's just take a look at what they're asking us to do. In number 1, we're taking the cube root of everything in here. So if we were to break it down, that's the cube root of a negative 27, cube root of m to the third, and the cube root of n to the sixth. So the cube root of a negative 27 is a negative 3. If you multiply a negative 3 3 times, you'll get to a negative 27. Now the cube root of m cubed, anytime that the power matches the root, if we were to write that m to the power over the root as a fractional exponent, 3 divided by 3 is 1, so it's just an m to the first power. An easy thing to remember is the cube root of m cubed is m. Anytime the power and the root are the same, it leaves us with just the variable. Now this one, we have the cube root of n to the sixth. So we could say, all right, n to the power over root. Oops, my brain divided already. Power over root would be, where's my undo? Oh, there we go. And then we would get n squared. Or you might say, well, if I have n to the sixth, how many n to the thirds can we fit in that? And n to the sixth can be broken up into n cubed times n cubed, and then that just takes us back to this idea. If we're cube rooting the same power, it just leaves us with n. So the cube root of n cubed is n, the cube root of n cubed is n, leaving us with n squared. So our final answer, just to make it look a little bit prettier, is a negative 3mn squared. All right, so once we kind of get the hang of this, they can go a little bit faster. On this one, we're going to take the fourth root of everything under the radical. So the fourth root of 625 is 5. The fourth root of x to the eighth. So how many x to the fourth can we fit? And we can fit 4 of those. I'm sorry, 2 of those. If we take the fourth root of each of those, it leaves us with an x and an x. So we're going to have an x squared. And then this one, the fourth root of y to the 28th. So how many y to the fourth can we fit into 28? And we can fit 7 of them. So it's going to be y to the 7th power. All right, next one. So this one, the sixth root of 49 squared. So I don't know, like, what really can we do with this? But the directions are saying to rewrite using a fractional exponent. So let's just start there. We're going to have 49. We put the power over the root, so 2 over 6. That 2 over 6 will reduce to the 1/3 power. And we can't, that's a cube root of 49, which we can't take without getting a decimal. It's not a perfect cube, so that'll just be our final answer on that one. All right, then we're going to move into solving some equations. When we solve equations, we're going to have to undo some radicals. I can see we have an x cubed. Before we deal with the x cubed, any numbers outside of that, so for example, this 7, we do have to get to the other side. So we're going to start by dividing both sides by 7. That leaves us with x cubed equals 27. And then to undo the x cubed, we are going to take the cube root. And if we do that to one side, we have to do that to the other side. So there's that cube root of x cubed. Anytime the power and the root match, it just leaves us with x equals. Now the cube root of 27 is 3. When you're solving an equation, you have to think about if you will have one solution or two solutions with a plus or minus. If the root you're taking is odd, that means you'll only have one answer. So the cube root of 27 is 3, x equals 3, done. The next example, we'll talk about what happens if the root you're taking is even, and then we'll talk about that. All right, so number 5, I guess very similar as we look at it. We have our x to the fourth. In order to undo the x to the fourth, we'll take the fourth root, but first that 7 has to go to the other side, so let's divide both sides by 7. That leaves us with an x to the fourth on the right is equal to 28,561. All right, so we got the x to the fourth alone. Now we're ready to take the fourth root. The reason why we do that is when the power and the root are the same, then it leaves us with just x. We're going to take the fourth root here. Now, here's what I was talking about on the last one. When you are taking an even root when solving an equation, so if this is even, that means we're going to have two answers. And how do we get two answers? That's our plus and minus, so positive and negative. And then the fourth root of 28,561 is 13. So x equals a positive 13 and a negative 13. All right, number 6. One cube has an edge length 5 centimeters shorter than the edge length of the second cube. The volume of the smaller cube is 216 centimeters cubed. What is the volume of the larger cube? All right, so what we're talking about is we have two cubes. A cube is a three-dimensional figure made up of all squares. So all those edge lengths are the same. So there's one. The other one is bigger, right? And all of those edge lengths, pretend this is a good drawing, those are all the same length. So it says one cube has an edge length 5 centimeters shorter than the edge length of the second one. So what we can do is we can define this one has an edge length of x. So this one would have an edge length that is 5 centimeters shorter. So it's going to be that first edge length, and we're going to subtract 5 to make it 5 centimeters shorter. What we want to remember is that because it's a cube, every dimension, here's our length is x, our width is x, and our height is x, and same thing over here. This is an x minus 5, an x minus 5, and an x minus 5. So we're told that the volume of the smaller cube is 216 centimeters cubed. So volume for a cube is equal to, I don't know, sometimes we see it with an E, the edge, and I guess we are using edge phrasing. So our edge to the third power. Because it's the same dimension, the length, width, and height, those are the dimensions we use for volume. Those are all the same. So edge times edge times edge, we can just say edge to the third power. Now we can plug in the things we know. We know that the volume of the smaller cube is 216. So we'll plug in a 216 for our volume. And then our edge of the smaller cube is an x minus 5. And we're going to raise that to the third power. And now we have an equation where we can solve for x. When we solve for x, we are finding out how long this is. And if we subtract 5, we can figure out how long this is. So it's very tempting to take this cubed and bring it in and cube everything inside the parentheses. You guys have done that before. You have cubed things inside parentheses. The distinction we need to make, though, is that this is more than one term. It's a binomial. If you had a trinomial, 4 terms, 5 terms, as soon as you see addition or subtraction inside the parentheses, we cannot cube everything. You just don't get the same answer. If we were to multiply this out, an x minus 5 to the third power would be x minus 5 times another x minus 5 times another x minus 5. And if you were to multiply that out, that's not x cubed minus 125. It's just not the same thing. Thankfully, though, because we're solving for x, we don't need to do any of that. We're just going to undo the operations. So our x is inside the parentheses. It is locked down with this cubed. So we want to undo the cube. So anytime that the power and the root are the same, they simplify away. So we're going to take the cube root of this side. Now, if we're going to cube root one side of our equation, we have to cube root the other side of our equation. The cube root of 216 is 6. And because that was an odd root, it's just a 6. We wouldn't have a positive and a negative. And also in the context of this problem, because x is representing the side of a cube, it's a physical measurement, the negative wouldn't make sense if it was an even root. So either way, just a 6 is equal to, now our root matches our power, so that simplifies away. This x minus 5 is just going to drop down, x minus 5. And now we have a pretty easy equation to solve for x. We'll just add 5 to both sides. So x is equal to 11 centimeters. And so did they ask us for the measurement of the larger cube? Let's take a look. What is the volume of the larger cube? Well, now that we know that this is 11, volume is equal to our edge to the third power. So we can just come back to this formula. The volume of the larger cube is our edge, which is 11 to the third power. And we get 1,331 centimeters cubed. So that will be the final answer we're looking for there. All right, moving on to the last few problems on this page. How can we rewrite each expression? So this is where we're going to simplify, kind of similar to what we did at the top of the page, but we might have some things that don't take the root of as nicely, and we got to think about how to simplify that. So here we're taking the cube root of this term. We are going to cube root each of these individually. So the cube root of 125 is 5. We're able to cube root it. Now the cube root of x to the ninth. So when we're dealing with the variables, how many x to the thirds can we fit into 9? Well, we can fit 3 of them, so we're going to have an x to the third out front. Do we have any leftovers? No. 3, we had x cubed, x cubed, x cubed. That made up the x to the ninth evenly. We were able to cube root those. Now, the y to the 7th, this one's going to be a little bit different. Y to the 7th is, break it up into groups of 3, y cubed, there's 6 of them, and we have this leftover. So if we say y to the 7th, how many y cubes can we get? Well, 2 of them, right? So that's going to give us a y squared. And then this one that's left over stays underneath our cube root. And now we have simplified. We cube rooted what we could, and that's as far as we could take this. All right, next problem, we have the fourth root of a fraction. What we want to do first is see if we can reduce the fraction. So in this fraction, what I notice is we have an a to the fifth in the numerator and an a in the denominator. So if you have a to the fifth over a, that's going to leave you with a to the fourth in the numerator. We have a b to the third, and our denominator is now a 625. We're taking the fourth root of that. All right, so when you have if you're taking a root of a fraction, we can break this up. Let's take the fourth root of the numerator over the fourth root of the denominator. All right, so the fourth root of the numerator, that one, I think I'm gonna need more space here. That one's going to be, maybe I'll do my work over here. So we'll come over here. So the fourth root of a to the fourth is a, and the fourth root of b to the third. Now, if it's b to the third, we have to have at least 4 of them so that the power matches the root and we can reduce it. We don't have enough b's to take the fourth root of, so that means that that just stays underneath our fourth root. All right, now the fourth root of 625. We could try to see if we can take the fourth root of that. Is that one of our perfect powers of 4? And it actually is. I was thinking it wasn't going to be. So the fourth root of 625 is 5. So that's simplified. I thought we'd be doing some rationalizing and getting really tricky with this problem, but that kind of worked out nicely. All right, last problem for this first side. We're taking the fifth root of this whole term, 288 x to the third y to the seventh. So first thing we can check is, can we take the fifth root of 288? And when we try that, we get a decimal. So it doesn't fifth root evenly, so we are going to reduce this. We want to see if we can break down the 288 with numbers that we can take the fifth root of. So numbers we can take the fifth root of. So 2 to the fifth power is 32. 3 to the fifth power is 243. 4 to the fifth power is 1024. So these numbers get big in a hurry. So we know that the 1024 is too big. We can't consider that. Do we think that 243 will fit into 288 evenly? No, that's not going to. So I'm wondering about the 32. Does 288 divide by 32 evenly? When we check on the calculator, we can see that it does. 32 fits in 9 times. So we're going to break down the fifth root of 288 with a 32 times 9. Now the fifth root of 32 is 2. And then the fifth root of 9 stays as a fifth root of 9. So I tried to leave a little bit of space here. You know, we have to still take the fifth root of the x's and the 7's. So we might have some things that we're able to take the fifth root of joining the 2. We may have some things that stay underneath the radical. We just kind of go through these one at a time. All right, so the fifth root of x to the third. Do we have enough x's to take the fifth root? Well, you have to have 5. If we only have 3, that's just not enough, which means that the x to the third stays under the radical. All right, now the fifth root of y to the 7th. So that is bigger than 5. So how many y to the 5th can we get out of that? Well, just 1, right? If we break that down, we can fit 1 y to the 5th, and then we've got the 2 extras, the y squared left over. So the fifth root of y to the 5th is y to the 1st, so that's going to go out front. And then that y squared left over stays underneath the radical. And that's going to be our final answer.